My name is Kevin Salvage and I'm the European Regional Development Manager for LEADER based in London in the UK. And I'd like to welcome you to this short video, an introduction to the Vectorscope display. For those of you unfamiliar with the Vectorscope display, it can appear confusing and complicated, with a rapidly moving trace dancing between a myriad of lines and markers on a graticule display. But once you get to know and understand how to use the Vectorscope display, it will provide you with an invaluable instrument for television and film production. What is the purpose of the Vectorscope display? The Vectorscope complements the waveform display for the purpose of measuring and testing television signals regardless of the format. While a waveform display allows a broadcast technician to measure the overall characteristics of the video signal, a vectorscope is used to visualize chrominance, which is encoded into the video signal. In digital applications, a vectorscope instead plots the CB and CR channels against each other. These are the two channels in digital formats that contain chroma information. As the vectorscope only operates with CB and CR signals, RGB has to be converted to CB/CR to be displayed on a vectorscope display. There is no luminance component displayed. So how does a picture translate into a vectorscope display? A 75% color bars test pattern translates into the following trace on the vectorscope display. As the vectorscope plots CB and CR channels against each other, here you can see from the CB and CR waveform displays how they result in the vectorscope display. So let's take a closer look at the vectorscope display. The visual pattern that the incoming chrominance signal draws on the vectorscope is called the trace, and the 75% color bars test pattern translates into the following trace on the vectorscope display. To assist us in explaining how to interpret the vectorscope display, we have added to the Vectorscope display a colour wheel around the periphery of the Vectorscope graticule. Each of the markers on the graticule indicates the location of the red, green and blue primaries, and the cyan, yellow and magenta secondary colours. The centre of the graticule is no colour. Hue defines colour on the basis of its position in the spectrum. The Vectorscope display starts with the red primary at 0 degrees, passing counterclockwise through the green primary at 120 degrees and the blue primary at 240 degrees, and then returning to red at 360 degrees. Saturation defines the intensity of the colour in the active picture. 100% saturated colour does not contain any white, and by adding white it reduces the saturation. In video, adding white will desaturate the colour, but white does not show up on the Vectorscope display. In this case, the picture on the right has been desaturated by adding white. However, the Vectorscope trace still shows the same display as the picture on the left, but you will notice that the desaturated picture looks pink instead of bright red. The LEADER Zen series Vectorscope graticule includes target markers for the primary and secondary colours, and can be configured to display either 75% colour bars or 100% colour bars. The 75% colour bars are 100% saturated, just 75% in level. What is the U and V axis? The perpendicular lines correspond to the U and V components of the chrominance signal. U is one of the two colour difference signals that modulate the subcarrier in the PAL system, and U corresponds to weighted B minus Y. V is the other signal and corresponds to the weighted R minus Y. What is the I and Q axis? Broadcasts require that the signal be encoded on the I and Q axis. These are a pair of modulation axes 90 degrees from one another, but rotated some 33 degrees counterclockwise from the R-Y and B-Y axis. The reason why the I and Q axis are rotated 33 degrees counterclockwise from the R-Y, B-Y axis is because the human eye does not respond uniformly to all colours. We see colour details best in the red/orange range. This also places skin tone measurements directly on the eye axis, and we'll discuss this further a little later. I and Q are the designators used to name the two colour components of the NTSC video signal. The Leader Zen series also supports a marker display, which allows you to move the cursor on the Vectorscope trace and display. D indicates the distance from the centre as a percentage. Degree indicates the hue as an angle. CB, the CB position as a percentage, and CR, the CR position as a percentage. What are Arab check markers? With the introduction of UHD TV resolution, broadcasters can utilise a new wider colour space, Rec 2020. The Rec 2020 colour space can produce colours that cannot be shown with the Rec 709 colour space. This has resulted in Arab publishing a new colour bars test pattern that supports both Rec 709 and Rec 2020. The Leader Zen series supports display of both the Arab STD-B66 and STD-B72 markers on the Vectorscope graticule. So now that we understand the information being displayed by the Vectorscope, let's see how it can be used in day-to-day television and film production. The Leader Zen series can simultaneously display the Vectorscope and picture image. The Vectorscope display also supports the capabilities to zoom in to show individual lines of the video signal. The Vectorscope display also supports both composite and component colour matrix displays. The composite format allows NTSC, PAL and automatic selection. The Vectorscope display can also be magnified with gain applied to the input signal in either ×1 or ×5, along with a variable adjustment up to ×2. A marker display window can also be enabled to allow the operator to locate exactly where on the Vectorscope graticule the trace being displayed is located. So how do you use a Vectorscope display? Well, colour matching cameras is one of the first uses for the Vectorscope display, and we use the Vectorscope display to adjust the camera's colour imagery before commencing shooting, and this is achieved by using the Vectorscope display and a colour test bar chart. This will ensure that the two camera colour imageries match identically, and you will not have to carry out any corrective work in post-production. So let's have a look and see how the Vectorscope display can be used to set up skin tone. Pictures that include people can be some of the most challenging to set up correctly and camera match. The main reason for this is that the human brain is used to seeing people every day and knows exactly what skin tone looks like. The other challenge we face is that people have different colour skin tone. Now we think of melanin as the main determinant of skin colour, but it's the blood under our skin that affects the hue. Melanin mostly affects brightness and saturation. We all have the same blood, so we all have the same hue. But hold on a minute, doesn't the Vectorscope display hue? So if that's the case, can't we use the Vectorscope to correctly display the image for skin tone? Earlier on in this video, we discussed the I and Q axis, and conveniently, skin colour displays a trace along the I axis, as can be seen from the Vectorscope display on the skin tone bar chart. all the various skin tones from left to right appear along the eye axis. This is an extremely useful feature if you're working in a live production environment or colour grading images that include skin tone. Simply adjust the image so that the skin tone in the image is close to the eye axis. Then you can carry out the other adjustments as required. The Vectorscope display features described in this video are available on all of the leader Zen series waveform and rasterizer products. If you have any questions or would like to receive a copy of the white paper that accompanies this video, please do not hesitate to contact me on the numbers currently displayed on the screen.